This is exercise 11.4, question 12, similarity proofs. In the diagram shown, we can see that AB is perpendicular to BC, and we can see that with a right angle there at B. And we're given also that BD is perpendicular to AC. We can see a right angle there at D. In the first part of the question, we have to prove that angle BAD, so this angle here, angle BAD, is equal to angle CDB, CBD up there. Now, notice there are no values or anything like that on any of the angles, so it would be a good idea to let that first angle, so let angle BAD equal alpha. So we'll just do that first. So in your first line of working, you can say let angle BAD equal alpha. We can see here we've got a right angle triangle. So triangle BAD is right angled here at D. So if this is alpha down there, we can say that this angle up here, so this alpha and this other angle up here have to add up to 90. So this angle ABD would equal 90 minus alpha. And we know that from basically from angle sum of a triangle. So reason angle sum of triangle ABD. We need to say which triangle we're working in because we've actually got 3 triangles here. So I'm just showing you the 3 triangles there now. In this question, let's just go back and look at what we're supposed to do. We're supposed to show that angle BAD, which is alpha, we need to show that it's equal to angle CBD. We can see that this angle here at B is 90 degrees. So if this angle here, so if angle ABD is 90 minus alpha, then this other angle in here must equal alpha, because 90 minus alpha plus alpha, so if I put an alpha in there, so 90 minus alpha plus alpha is equal to 90 degrees. So we can write that in our next line of working, that angle CBD is equal to alpha because those 2 angles there are adjacent angles in a right angle, or you can just say complementary angles. Therefore, we've proven that angle BAD, which equals alpha, is equal to angle CBD, which is also equal to alpha, and we can write that in our next line of working. So we've got angle BAD equals angle CBD because they are both equal to alpha. Now, in part B of the question, we have to prove that triangle ABD is similar to triangle CDB. Now, in those 2 triangles, we've already proven that these 2 angles here are alpha, so we can already see that angle BAD is equal to angle CBD because it was proven above. So we can write that in the first line of our working. We can also see that we know that this angle down here, so angle angle BDA is 90, but also angle BDC is 90 because BD is perpendicular to AC, so we can write that down as well. So we've got that angle BDA is equal to angle BDC, which is equal to 90, because BD is perpendicular to AC, and I'll just put a little right angle symbol in there as well. So we can see that we've got 2 angles in both of these triangles that are the same. So therefore we can say that triangle ABD is similar to triangle BCD because the reason being that all the angles are equal. Now remember, we only need to prove that 2 of the angles are equal. So we've got alpha and right angle and alpha and right angle in the other triangle. So naturally the third angles will be the same. So therefore they're similar by equiangular. Now, in the next part of the question, we have to show that BD squared equals AD times DC. So when you see this little dot here between the AD and the DC, it actually is a multiplication symbol. So this says show that BD squared is equal to AD times DC. Now, because we've just proven that the 2 triangles are similar, what I'm actually going to do, I'm going to draw them in separately so that we can see which sides are corresponding sides. So these two triangles, triangle BAD is drawn there, and triangle BCD is drawn over here. And I've just marked in the angles alpha and the right angles in as well. So once you've proven that two triangles are similar, and we have in this case, we can then proceed to talk about ratios of corresponding sides being in proportion. Now we have to show that BD squared equals AD times DC. So what we need is two ratios, and that BD has to appear in the ratios twice. So we need a ratio with BD and its corresponding side, which would be, look, we've got the blank angle there and the right angle. So the matching side in this triangle here would be CD, the blank angle and the right angle. And in this other triangle here, the BD over here is from the alpha to the right angle, and that matches up with the alpha and the right angle over here, which is AD. Now those sides that I just spoke about, BD twice and AD and DC, all appear in this, show that BD squared equals AD times DC. So we're going to do the ratio with those sides. So we say, let's go from left to right. So in this first triangle, BD, which is blank angle, right angle, over DC, or CD, is equal to a little mistake there. So BD in the first triangle, which is blank right angle, over DC, blank right angle, is equal to AD, so alpha right angle, over BD, alpha right angle. So we're going from left to right. BD over DC equals AD over BD. Reason that they are matching sides of similar triangles that are in proportion. So we can always make that statement once we've proved that two triangles are similar. Hence we can cross multiply here, and we can only do that because fraction equals fraction. So if you bring the BD up there, we end up with BD squared, take the DC up over there. So BD squared equals AD times DC. So now we've shown that BD squared equals AD times DC. Now in the last part of the question, we have to hence find BD. Well, we've been given the length of AD, which is 16, and the length of DC is 9, so we just substitute it into this result from part C. So we know again that BD squared is AD times DC. Putting in that AD is 16 and DC is 9. We multiply those two and we get BD squared is 144. And therefore BD is the square root of 144, which is 12. And that is the end of that question.